Okay, class, last time we looked at how to convert our polar coordinates, which is a distance r along the angle formed at theta, and we created a rectangular coordinate for that. And now we want to take rectangular coordinates and find the corresponding r theta for polar coordinates. So let's look at just the 4 specific situations where the point happens to be on one of the axes, either the x-axis or the y-axis. Okay, so for this example here, they're using A. I'm going to go ahead and say use a coordinate ordered pair, and we'll just substitute an actual number for A. So to be at 5, 0 is to be on the x-axis on the right side of the y-axis. And so we always get our distance from how far along we are on that axis, so that's 5 units, and then the angle along from the polar axis is 0. So these look the same, but they're interpreted differently. If I come over here and instead I've got a 5 on the y-axis, so we would call that 0, 5, I'm still going a distance of 5, so I still want a 5 over here, so it starts to look different, right? And then the angle, I went pi over 2 to decide what direction to take from the pole, and so that's going to be the angle pi over 2. Okay, and we can generalize that for any number that's on the x-axis or y-axis, and that's what they've done here with the A. If we go ahead and feed this a 5, and then negative 5 would step us back here in rectangular coordinates. And that puts us on the x-axis on the left side of the y-axis. And so there's no such thing as a distance of negative 5. So we would just take the absolute value of that, or just strip the negative. We're going a distance 5 still, but we're going along a different angle. And the angle that coincides with that is pi. And over here, if we go below the x-axis and we're on the y-axis, that would be like 0, negative 5. And again, the distance we're going is 5, but the direction angle is given to us by 3 pi over 2. Okay, so we've got coordinates here, rectangular coordinates of 0, 3. That 3 is going to be up along here, where the angle is pi over 2. And it's 3 units away, so 3 pi over 2 is the polar coordinates that match. Okay, so let's look at a specific situation now where the point is not on the x-axis or the y-axis. That means it's in one of our quadrants. In this particular case, if I go x by 2 and then negative 2 for y, it's going to put me down here in quadrant 4. So there's our point in rectangular coordinates. And then remember, our distance formula says that the distance between any 2 points is equal to the square root of the difference in the x's quantity squared plus the difference in the y's from point 1 to point 2. Now notice that we're always using the origin 0, 0, which is the pole, as our second point. So this is just going to be the distance is equal to the square root of 2 minus 0 squared, so that's going to be 2 squared, plus negative 2 minus 0 squared, so that's going to be negative 2 squared. So we get a square root of 8. Now if you remember, we want to rewrite this as 4 times 2 and bring the 4 out. Square root of 4 is 2, so we'll leave it as 2 times the square root of 2 is the distance here. Okay, so we've got the distance part figured out. Now we need the angle. Okay, so this angle, which is the same as this negative angle, right? So what we're going to use, it's great that we get an ordered pair, because remember what the tangent is. The tangent of theta is equal to y over x. So we've got a y and an x, and so from negative pi over 2 to pi over 2, we can find the inverse tangent. So the inverse tangent is going to be y is negative 2, x is 2. So the angle is the inverse tangent of negative 1. And that equals negative pi over 4. Okay, so we've got the pieces we need, so our polar coordinates here. It's going to be distance, 2 times the square root of 2, along a trajectory that matches the angle of negative pi over 4. Now, if I wanted to write this with a positive angle, remember we can locate polar coordinates in more than one way. So if we wanted to do, here's the negative pi over 4. So if I go from the other direction, I just have to take pi over 4 away from a full 2 pi. So that's going to be 2 pi minus pi over 4, 7 pi over 4.